energy. ये आवाज आ रही है? कैन यू हियर मी? So okay. So we have a cylinder is kept on the edge of a table as shown. When slightly disturbed, the cylinder rolls from the corner without slipping. Find angle OP with vertical when cylinder loses contact with table. Also find ratio of kinetic energy of rotation to kinetic energy of translation when OP is horizontal. So if you keep your pencil at the edge of your table, right, and if you see the motion of the pencil, if you slightly disturb it, you will see that the pencil actually rotates about the corner for some time, and then it will lose contact with the table. All right. Now, anyone? I'll give you a hint. Chalo. Should be able to do this. Yeah, 18 question hai. So I can draw properly. This is the side of the cylinder. The center of the cylinder, according to the diagram, is right at the edge of the table. So when the cylinder begins to roll down the corner, then after some time, the cylinder will be like this. And the center of the cylinder will be here. So basically, it is this angle theta that we have to measure. At what theta does the cylinder the surface? Now, whenever the statement leave the surface comes along, that simply means that the n is equal to 0. First thing. Second thing, please tell me that up till the point the cylinder is leaving the surface, okay? Up till the point the cylinder is leaving the surface. Up till the point that cylinder is leaving the surface, what is the type of motion of the what is the type of motion of the हाँ रोलिंग हो रहा है बट इसके रोलिंग हो रहा है बट इसके जो हाँ CY moves in a circle. Rotation around the yes, good Taran, yes. Rotation around the point of contact. So basically, you can consider this to be rotation and not rolling. You can say that the point of contact stationary. So you can say that it is rotation about the point of contact. हुआ भाई, कोई तो करो. The answer will be the same as before. It will not be any different. So by what distance has the center of mass come down? This distance is r into 1 minus cosine theta. So if I apply the work energy theorem, I am going to get plus mgr 1 minus cosine theta is equal. Now, I can either consider it as rolling or I can consider it as rotation. Both will give me the same answer. Yeah, Shama, kya karna? If I consider it rotation, I will get the same answer as I will get rolling. Yeah? So you can write here simply 3 by 4 mv square minus 0, right? Yeah. Or please notice what I am doing. You can write here half I omega square, which will be equal to half into I, which will be equal to mr square by 2 plus mr square into omega square. So what have I done here? I have considered rolling. And what have I done here? I have considered only pure rotation about point of contact. Now, the question arises, could I have done this previously? Was this also valid when we were doing, when we were talking about rolling of a cylinder on an inclined plane maybe, or the cylinder moving, in on a flat surface? Was this also applicable? And the answer is yes, it was. Okay, and after this question, I'm going to explain how that is possible.
सर बट उस केस में ओनली रोटेशन तो नहीं था ना?
हाँ सर, ट्रांसलेशन के था.
Yes, yes, yes. आ रहा हूँ, उस पे आ रहा हूँ. I'm coming. Okay, I'll come to that. This is the first instance where I am sort of changing the axis. Although this object is not fixed, I am considering the object to be fixed at this point. This is one equation that I get, and the other equation I get from the fact that this center of mass is executing rotational motion. So after loss of contact, I can draw the tangential and the radial axis. And I can draw the forces acting on the object, mg only. So I get mg cosine theta is equal to half mv square. Sorry, mv square. And when you place the values, you are going to get cosine inverse of 4 by 7, which was the angle, if you remember, last class में हमने किया था. This was the same angle as जब सिलेंडर को हेमिस्फीयर पे रोल करते हैं, the angle of leaving with the vertical is again cosine inverse of 4 by 7. Okay. Now, please answer the second part of the question. We have discussed that as well in the last class. Can you apply it? अबे सेकंड वाला क्या खासियत है सेकंड वाले क्वेश्चन की? So we are interested in finding, no, yeah, we are interested in finding the kinetic energy of ratio of kinetic energy of rotation and translation when the cylinder is here. Okay. So what happens when the cylinder loses contact with the table? What happens when the cylinder loses contact with the table? What happens when the cylinder loses contact with the table? क्या होता है? Free fall.
सर ओमेगा सेम रहता
बिल्कुल सही.
कॉन्स्ट
Yes, yes, yes. So the moment the cylinder leaves the table, torque on the cylinder has become zero, and therefore any further change of rotational kinetic energy is not possible. However, since gravity is still acting on the cylinder as before, change in translational kinetic energy is absolutely possible. So what we need to do is that we need to find the kinetic energy of translation of center of mass and the kinetic energy of rotation about center of mass. And we need to fix its value. So rotational kinetic energy कहाँ से कहाँ change हो रही है? ये 0 से theta angle जो जा रहा है. Can you tell me what is the rotational kinetic energy at this point? हाँ. जब ये हॉरिजॉन्टल हो गया था, जब ये हॉरिजॉन्टल हो गया था, तो total kinetic energy which is possessed by the cylinder is mgh, or rather mgr. The center of mass has come down by a distance of r. Now, what you need to find is that out of this mgr, what proportion is translational kinetic energy and what proportion is rotational kinetic energy. नहीं, 3:4 आंसर नहीं. नहीं नहीं गलत. नहीं था. 2:1 नहीं है. नहीं नहीं शोना गलत. Hey, Anish, no. देखो, since theta is equal to cosine inverse 4 by 7, the total kinetic energy at total kinetic energy at point of detachment, point of leaving will be equal to what? mgr into 1 minus cosine theta, which is 4 by 7. This will be equal to 3 mgr by 7. Total kinetic energy है at the point of leaving. Now this consists of kinetic energy of translation and kinetic energy of rotation. This also consists of kinetic energy of translation and kinetic energy of rotation. However, these two guys are same because after leaving, the kinetic energy of rotation does not change. Very good, Vedant. Yes. The kinetic energy of rotation does not change. However, these two guys, they are not equal. Okay, because the kinetic energy of translation has changed. So if from here you can figure out what is the value of kinetic energy of rotation. नहीं यार, थोड़ा गड़बड़ हो गया, देखो जरा, थोड़ा सा। If from here you can figure out the kinetic energy of rotation, then you can put it here and you have found then the ratio of, because total तो आपको मालूम नहीं है क्या। नहीं, कहाँ पे दो वेरिएबल है? नहीं है ना, आपस में कनेक्टेड है ना, v is equal to r omega होएगा, राइट?
सर बट फर्स्ट वाली इक्वेशन में ट्रांसलेशन के ही और सेकंड वाली में अलग है ना?
हाँ, अलग अलग है, लेकिन अगर यहाँ से आपको रोटेशनल काइनेटिक एनर्जी मिल गई तो वो वैल्यू जब आप यहाँ डालोगे तो ये ऑलरेडी मालूम है ना आपको टोटल।
हाँ सर, अच्छा उसमें से एक वर्कआउट कर सकते हैं। हाँ
भाई इतना टाइम होने लगता है। ये देखो आंसर यहाँ लिखा हुआ है 3/4 MB² है ना। 3/4 MB² कैसे आया? हाफ MB² प्लस 1/4 MB² से आया। So this is the kinetic energy of translation. This is the kinetic energy of rotation. इस रेशियो में है ही। square. So MV² is equal to 4 mgr/s. Kinetic energy of translation, which is half MV², must be equal to 2 mgr/s. Kinetic energy of rotation, which is 1/4 MV², must be equal to mgr/7. Right? So this mgr/7 kinetic energy, this mgr/7 kinetic energy is now fixed. So this is equal to mgr/7. This means that the kinetic energy of translation must be 6 mgr/s. And therefore, the ratio of kinetic energy of rotation to translation must be 1/6. I'll change the slide. हाँ मैं फिर से Okay, so what is happening is that there are 3 distinct configurations of the cylinder that we are working on, where it is leaving the surface. And the third configuration is that when it has left the surface. So here is the line OP. In this case, here is the line. So let me call this configuration 1, 2, and 3. So for configuration 3, center of mass has fallen distance r. So total kinetic energy at 3 must be equal to mg. This must be equal to some kinetic energy of translation plus some kinetic energy of rotation. Similarly, at configuration 2, the total kinetic energy at 2 must be mgr1 minus 4/7, which is equal to 3 mgr/7. Right now, let's say अब आप इससे आगे नहीं बढ़ना चाहते, आप इसमें अब और कुछ नहीं करना चाहते, इतना समझ में आया सबको? दिस इज अंडरस्टूड बाय ऑल, राइट?
Yes, sir.
Yes, sir.
Yes, sir.
अब आप देखो, so there are so many ways that you can interpret this. Now you know that whatever increase is going to happen, whatever increase is going to happen is going to be in the kinetic energy of translation. Whatever increase is going to happen is going to be the increase of kinetic energy of translation. Right? So this means that from point 2 to point 3, so from from configuration 2 to configuration 3, from configuration 2 to configuration 3, increase in translational kinetic energy is 4 mgr by 7, right? कितना ही आएगा? कितना difference है वो? 4 mgr by 7. And increase in rotational kinetic energy is equal to 0. ये समझ आया? नहीं?
Yes, sir.
Yes.
So if the object goes from 2 to 3 and its translational kinetic energy increases by 4 mgr by 7 and its rotational kinetic energy does not increase at all, this means that three mgr by 7 must be equal to translational kinetic energy plus rotational kinetic energy. So if this is kinetic energy of translation, then this is kinetic energy of translation divided by 2. Right? I can just see from the above relations. Or if you want to write it, you can write it like this: that look, if this is the kinetic energy of the rotation, then this is twice the kinetic energy of rotation. So I can say that look, 3 times the kinetic energy of rotation is equal to 3 mgr by 7, and therefore I come to the conclusion that at point 2, at configuration 2, kinetic energy of rotation is equal to mgr by 7. Yeah, yeah, समझ में?
Yes, sir.
So if kinetic energy of rotation is mgr by 7 at configuration 2, the kinetic energy of rotation at configuration 3 must also be same, must be equal to the kinetic energy, must be equal to the kinetic energy of rotation at configuration 3. So if this is mgr by 7 and the total is mgr, then obviously kinetic energy of translation must be equal to 6 mgr by 7. ये आया समझ में? Clear?
Yes, sir.
Diksha?
Yes, sir.
Chetal? So I want to now talk about that thing that I was telling you. So this is
सर एक
called,
डाउट आया
हाँ,
एक बार लास्ट सेकंड
ये
सर
वाला
एक बार हाँ सर सर 2 के बाद कांटेक्ट छूट जाएगा ना तो सर हम ये कैसे प्रेडिक्ट करेंगे कि जब ओपी मतलब हॉरिजॉन्टल हो जाएगा तब वो मतलब आर ही डिस्टेंस नीचे गया उससे ज्यादा नहीं है उससे कम नहीं मतलब एक बार कांटेक्ट छूट गया फिर तो मतलब रोलिंग का कॉन्सेप्ट ही चला जाता है
हाँ, तो उससे फर्क क्या पड़ता है?
सर तो ओपी 90 मतलब ओपी जब हॉरिजॉन्टल होगा तब नेसेसरी थोड़ी ना कि वो आर डिस्टेंस से नीचे आया होगा कांटेक्ट छूट गया ना
सर बट किसी पॉइंट पे तो आर पे आया होगा।
हाँ नहीं, ये क्या बोलते हैं, अ, हाँ नहीं, सही बोल रहा है, सही बोल रहा है। तो मेरे को एक बार ये क्वेश्चन देखना ना जरा, 80 वाले, आई थिंक 1997 2000, मतलब 1997 और 2003 या 4 के बीच में है। एक बार इस क्वेश्चन को देखना। आई थिंक दे हैव नॉट सेड दैट इट विल बिकम हॉरिजॉन्टल, दे हैव सेड दैट इट विल एक्चुअली ट्रैवल अ डिस्टेंस ऑफ r. So you are absolutely I think you are absolutely correct. I think in the question they have mentioned that the center of mass has become level with the edge of the table. तब तो आ जाएगा ना, तब तो ठीक है ना?
हाँ सर
Very good. हाँ
सर जब भी वो ओपी मतलब गिर गया वहां से, छोड़ दिया उसने कांटेक्ट, तो उसके बाद वो फ्री फॉल में है, लेकिन एक पॉइंट ऑफ टाइम पे तो वो आर डिस्टेंस पे आ ही जाएगा ना।
हाँ, वही मैं बोल रहा हूँ ना। तो क्वेश्चन जो ओरिजिनल क्वेश्चन है उसमें यही मेंशन्ड है that the center of mass has become level with the edge of the table, is at the level of the edge of the table.
बट जब वो वैसे होगा तभी तो ओपी हॉरिजॉन्टल ही है।
जरूरी इसलिए नहीं है क्योंकि एक बार जब रोटेशन और ट्रांसलेशन इंडिपेंडेंट ऑफ ईच अदर हो गए तो फिर मेरे को मालूम नहीं है ना क्या होने वाला है। मेरे को लग तो रहा है कि ओपी हॉरिजॉन्टल होएगा जब वो डिस्टेंस आर ट्रैवल करेगा, बट आई डोंट थिंक आई कैन बी श्योर। एक बार ओरिजिनल क्वेश्चन देखना, एक बार look at the original question. I think they have given that center of mass is at the edge of the table, is at the level of the edge of the table. Okay. So instantaneous, अरे आर्यन किसी भी आईआईटी के पुराने पेपर्स देखना ना, कोई स्पेशल बुक थोड़ी ना आती है। मतलब बुक आती है, बट एनी बुक which contains past IIT papers. Instantaneous axis of, okay, so basically what this is, I don't really like this concept, and there are reasons for that which I'm not going to discuss. Instantaneous axis of rotation, IAOR. This is a device, this is a tool which can be used to convert rotation plus translation into just rotation. So any object executing translation plus rotation is executing only rotation about the instantaneous axis of rotation. Now, the reason why I don't like this concept
Constantly
is that
change हो रहा है.
instantaneous change होता रहता है. हाँ, तो कुछ क्वेश्चंस में हमें डेफिनेटली इसका फायदा मिलेगा. कुछ क्वेश्चंस में डेफिनेटली हमको we will benefit from this. But then in many questions there will be problems because the instantaneous axis of rotation is changing. So I will tell you the instantaneous axis of rotation of a cylinder rolling is the point of contact. वो कैसे workout हुआ obviously I will tell you. But as you can imagine, in fact ये I think पहले ही objection raise हो गया कि अगर horizontal सरफेस पे एक सिलेंडर रोल करते हुए आगे चला जा रहा है तो इंस्टेंटेनियस एक्सिस ऑफ रोटेशन कंटिन्यूअसली उसका मूव कर रहा है, राइट? ओके, पहले ये कैसे निकालते हैं इंस्टेंटेनियस एक्सिस ऑफ रोटेशन? बाय द वे एक क्वेश्चन मुझे पूछना था, मैं भूल गया. Generally, I forget to ask because I think it's obvious, but you will not perhaps think it is obvious. So a cylinder is rolling along, right? What is the direction of friction? What is the direction of friction? Before we come to IAR, what is the direction of friction? हाँ, मतलब दो ही plausible choices है ना, या तो से ज़्यादा. Forward, forward, backward. Anybody else? Or कोई? Supposing the friction is forward. Along B. Okay. Supposing the friction is forward. Okay. Supposing. I don't know whether this is the correct answer or not. Then what will happen to the velocity of the rolling object? What will happen to the velocity of the rolling object? भाई फ्रिक्शन आगे की तरफ है. What will happen to the velocity of the rolling object? Yes, the velocity of the rolling object must increase. आगे की तरफ velocity की तरफ force लगी हुई है ना, और तो कोई force लगी नहीं है. So the velocity of the rotation must, velocity of the rolling object must increase. Everybody agrees with this? Hello, hello, hello.
Yes, sir.
What will happen to omega due to torque due to friction? What will happen to omega due to torque due to friction?
It will decrease.
Decreases, right? Because omega is clockwise and the torque due to friction is anti-clockwise about the center of mass. Therefore, If friction is in the forward direction, this tells me that as time goes on, the velocity of the object will increase, whereas the angular velocity of the object will decrease. So after some time, it will be moving faster and faster, but rotating, the rotation will come to a stop. Is that what happens? अगर आपने एक पेंसिल को अपने डेस्क पे अभी रोल कर दिया, आपके पास सबके everybody has a pencil or a pen which is cylindrical, not that hexagonal wala cross section wala pencil, but a cylindrical pencil or a pen. If you roll it on your desk right now, does the velocity increase and omega decrease? Yes or no? Does the velocity increase and omega decrease? No, it cannot, right? Does not make sense. Reverse happens. Okay. So what we are saying is that maybe friction is in the backward direction. Now, supposing that friction is in the backward direction, what will happen to the velocity over time? Supposing friction is in the backward direction, what will happen over time? Suppose
So
friction
velocity
velocity
reduces,
will
Decrease होगी.
and what will happen to omega?
increase.
Please.
Increases. इसका मतलब ये हुआ कि थोड़े देर बाद ये ऑब्जेक्ट तो रुक जाएगा, लेकिन ये और तेज गोल घूमने लग जाएगा. Is that what happens?
No, sir.
No, sir.
Therefore, friction should be where? Therefore, friction should be where? Very good. Yes. Friction is absent. Right? Friction is not there. Friction between a rolling object on a horizontal surface की मैं बात कर रहा हूँ.
सर
उसके
बट
ऊपर कोई एक्सटर्नल फोर्स नहीं लगी. हाँ
रोलिंग के लिए नेसेसरी होता है ना स्लिपिंग के.
हाँ. जब कोई एक्सटर्नल फोर्स लगी है, जैसे हमने क्वेश्चंस डिस्कस किए थे, तब फ्रिक्शन आ जाएगा. लेकिन आपको ये क्लैरिटी अपने मन में रखनी है कि अगर एक ऑब्जेक्ट हॉरिजॉन्टल रोल कर रहा है, तो उसके ऊपर फ्रिक्शन जीरो होता है. हाँ, net torque and friction, net torque and force is zero because velocity over time does not change and omega over time does not change. However, your pencil does stop on the table. Your pencil does stop on the table. So in this perfect Archimedean world where we have this perfect rigid body, no, you don't need to balance V protection. You need to balance force. Velocity does not require any balancing thing. Velocity is velocity. You can change with the application of a net force. Angular velocity you can change with the application of a net torque. So in this Archimedean perfect world where we have this perfect rigid body which is kept on a perfect horizontal rough surface, if I manage to get the cylinder or the sphere rolling in this perfect world, then it will never stop. It will never stop because the friction is absent between the sphere or the cylinder and the horizontal surface. In the real world, however, it does stop. Can anybody guess what imperfection may lead to this? Air resistance. Yes, definitely. Yes, that is one of the factors, but not the major factor, surprisingly. Supposing that I get rid of air resistance, supposing that I put this rolling cylinder in a vacuum chamber, then what do you think? Will it stop or will it just keep on going? I'll tell you the answer. It will stop. And it will stop in roughly the same amount of time, covering the same amount of distance as normal without vacuum space. No heat. No. I'll discuss the answer in the next class, but I will tell you where the answer is. The answer is given in the H.C. Verma rotation chapter in the last paragraph. जो last paragraph लिखा है, जो last सब topic है, नहीं आ रहा है, जो last सब topic है H.C. Verma में of rigid body dynamics, उसमें उन्होंने इसका explanation दिया है, right? And I will be talking about the explanation in the next class. However, right now you need to understand that in our perfect world, in this perfect world, there will be no friction. So no friction. Okay. Coming back to the instantaneous axis of rotation. Very quickly. So supposing that this is the rigid body. And on this rigid body, you happen to know that the velocity of this point A is like this. And you happen to know that the velocity of point B is like this. So on a rigid body, you know the velocity of 2 points. You know the velocity of 2 points. This is the net velocity. Remember that A and BB are net velocities. That means that they are the vector sum of rotation and translation. Are net velocities as the rigid body is executing rotation plus translation. So to find the instantaneous axis of rotation, what you do is you draw a perpendicular to velocity 1 and you draw a perpendicular to velocity 2. Wherever these lines meet, this is the instantaneous axis of rotation. Point of intersection of lines drawn perpendicular. अगर आपको दो ऑब्जेक्ट्स बोल रहा हूँ, एक ऑब्जेक्ट के ऊपर 2 पॉइंट के वेलोसिटीज मालूम है, तो फिर इस केस में आप उन दोनों वेलोसिटी वेक्टर के परपेंडिकुलर एक लाइन बनाएंगे, मतलब 2 लाइन बनाएंगे, और ये दोनों लाइंस जहां पे इंटरसेक्ट करेंगे, that will be the instantaneous axis of rotation. So you can say that, look, about the center of mass of the object, which may be here, so it may have some velocity of center of mass and it may be rotating with some value of omega, but about the instantaneous axis of rotation, it only has pure rotational motion. Only has pure rotational motion. So it is only rotating about this instantaneous axis of rotation. Please take a screenshot of this. I'm going to the next slide.
सर लेकिन सर 2 पॉइंट से हम पूरे बॉडी पे कैसे कमेंट करें?
हाँ, 2 पॉइंट से सारे बॉडी का यस 2 पॉइंट से सारे बॉडी का रिजिड बॉडी है ना, तो रिजिड बॉडी का तो डेफिनेशन ही ये होता है कि द डिस्टेंस बिटवीन एनी टू पॉइंट्स मस्ट रिमेन फिक्स। तो आपको ऐसा लग रहा है कि इनफाइनाइट पॉइंट्स है, इनफाइनाइट ऑब्जेक्ट्स है, उसमें दो को चूज करके बाकी कैसे डिस्क्राइब होगा, बट द पॉइंट इज दैट they are all connected to each other in such a manner that you only require two point velocities of two. Can anybody tell me the exception to this rule? ये rule कब fail हो जाएगा? There is a very obvious case where this rule will fail. There is a very obvious case when this rule will fail. What is
Points coincide.
that? नहीं, coincide वाला नहीं है। दो अलग अलग पॉइंट्स हैं, लेकिन ये रूल काम नहीं कर रहा है, क्यों?
जब ये पॉइंट ऑफ इंटरसेक्शन बाहर रहेगा से करके।
नहीं नहीं नहीं
सर परपेंडिकुलर्स पैरेलल हो जाएंगे।
So if on the rigid body you do know the velocities of two points, but both these velocities are parallel to each other, okay, then of course it will fail, because perpendicular lines intersect nahi karenge. So what you are supposed to do then, supposed to join the two, and the instantaneous axis of rotation is at that point where if this distance is r1 and if this distance is r2, right? So that we call it RA and R2. Then EA upon RA is equal to EB upon RA. तो VA upon RA होता क्या है? Basically, I'm just saying that about this point, omega must be B is equal to R omega, right? So omega is equal to B by R. Please take a screenshot. This is if
सर बट रिजिड बॉडी में ये दोनों पॉइंट का ट्रांसलेशन वेलोसिटी सेम नहीं होना चाहिए।
नहीं, यहाँ पे ट्रांसलेशन नहीं हो रहा है ना, यहाँ पे ट्रांसलेशन प्लस रोटेशन हो रहा है।
ओके,
ट्रांसलेशन प्लस रोटेशन हो रहा है, और आपने जो दो पॉइंट चूज किए रिजिड बॉडी पे, ड्यू टू ट्रांसलेशन प्लस रोटेशन, इट टर्न्स आउट दैट द वेलोसिटीज ऑफ दोस टू पॉइंट्स आर पैरेलल। देन यू आर गोइंग
ओके सर।
Please take a screenshot. We are moving ahead. So if I have this rolling object, right? Where is the instantaneous axis of rotation? So you can find it out by using the method that I have just shown you. Or you can simply say that the point which is at rest instantaneously is the instantaneous axis of rotation. I want to figure it out using the thing that I just told you. So I know that the velocity of this point is 2. And I know that the velocity of this point is right. So if I were to draw a perpendicular to this, it would be like this. And if I were to draw to this, right? Because remember, ये vertical से 45 degrees. अगर rolling हो रही है तो, अगर rolling हो रही है तो इस point की velocity due to translation is v. Velocity due to rotation is also v. Therefore, the net velocity is root 2. This is the instantaneous axis. Okay, so if you are lucky enough कि हाँ भाई एक रिजिड बॉडी रोटेशन प्लस ट्रांसलेशन कर रही है और उसके एक पॉइंट को आप देख रहे हो जो इंस्टेंटेनियसली एट रेस्ट पे है, कोई प्रॉब्लम नहीं. That will become the instantaneous axis of rotation. You don't have to carry out any calculations. If you are not lucky enough, you can't see a point which is instantaneously at rest on a rigid body, then this is what you do. I'll give you another example. So coming back to the ladder wala problem. Sorry. So the ladder begins slipping. Where is the instantaneous axis of rotation? Where is the instantaneous axis of rotation? Nine. कॉर्नर पे नहीं है, बिल्कुल नहीं. नहीं 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 नहीं. अगर ये लैडर स्लिप कर रही है तो ये वाला पॉइंट किधर मूव कर रहा हो? हाँ, सही पकड़ा करो. सो दिस, नहीं नहीं शिवेन, गलत, उल्टा कर दी. ये वेलोसिटी इधर होएगी, ये वेलोसिटी इधर होएगी, राइट? हाँ हाँ, yes. So you can say that the ladder is executing pure rotation about this one. Okay, so I'll give you a question. I'll leave you with a question. The question is very, very simple. Again, please try to do it and send me on WhatsApp. We will discuss it in the next class. There is no friction. And initial theta is equal to pi by 2. That means that ladder almost vertical. Find theta at which will lose contact with the vertical wall. Find theta at which the ladder will lose contact with the vertical wall. solve this question? It is not an easy question. हाँ, pi by 2 का मतलब हुआ कि starting vertical है, ladder जो है ना almost vertical. मतलब starting ऐसे हो रही है. In the beginning, the ladder is like.
यार अगर पाई बाय 2 पे रहेगा तो गिरेगा कैसे?
अरे मतलब थोड़ा सा काम है, ठीक है. I'm doing this so that the angle becomes sort of a single object. अगर मैं कोई initial angle दे दूंगा तो उसमें थोड़ी और problem आ जाएगी. You can take the initial angle theta naught as well. But pi by 2 is clear, so that calculation becomes slightly easier. It is not an easy question. Okay, it is a difficult question. See if you can. It will require everything: work energy theorem, concept of torque, concept of translation, everything that we have discussed up till now. Moment of inertia, everything that we have discussed. Okay, so I'll solve it in the next class, and I'll see you then. इसके बाद भी class है या no?
सर इसके बाद क्विज सेशन है, शायद से इसी पे होगा.
नहीं दूसरे उस पे मैसेज आया.
चलो.